Video, I'm going to derive and use the integrating factor method. Okay, let's get started. So in this method, we take an equation of the form dy by dx plus some function of x times y equals some function of x. Okay? So we're going to take an equation of this form and we're going to solve it in the following way. If we were to multiply both sides of this equation by something called the integrating factor. Well, what is that? Well, the integrating factor, let me use a color that's a little bit nicer. We're going to go with blue. And say here, and say done. Okay, so if my integrating factor is just some function of x, okay? So I'm going to multiply both sides of my equation by this integrating factor. So I'm going to keep my dy by dx, okay? Now here I'm going back to blue. This is my r of x, okay? I'm going to keep my p of x, y equals q of x times that r of x, okay? So what do you notice here? Well, the insight, okay, into how to solve this type of problem, okay, is to recognize that we're starting to look, if you look on the left-hand side of this equation, you're starting to see the product rule. Okay, if you remember the product rule, what is the product? Let me go back to black here. Okay. Well, the product rule is, if we just imagine u and v, instead of u and v for the product rule, we have r and y. Okay, so what you have is you have r of x, this is y prime, okay, plus, now I'm going to go in and I'm going to use a different color here. Let me go with orange, okay? Okay, if it was the product rule, okay, it would be ry prime plus y r. Oh, I've got the y here. So actually, let me keep my black color here. Let me go with this one. We'll make this one black, okay, because that's the same. So I'm going to put the, it would be, so it's r y prime plus y r prime, okay, so, or r y prime plus r prime y, if you like. Okay, so I'm going to leave this one black, but what we need to enforce, okay, let me go back to here, is this. This is r prime. Let me just make it dr by dy. That's r prime. So look, if let me go with a different, let me try another color here. Let's go with, keep that one. We'll go with green, okay? If we could force, you see this? R of x times p of x. If we could force that to be equal to, sorry, not y. This should be, I got this one a little bit off here. It's this orange here. This should be dx. Let me clear that up. It should be dx, okay? So if we could force r of x times p of x to be equal to dr dx, okay, then, okay, let me just put this here. Let me put back the r of x. Okay, then what happens is we can make the whole left side of this equation, okay, this is just the same thing as r, y. This is the integrating combinations, okay? We're basically going, it's the product rule, but we learned this in a previous lesson that you can go from this is the product rule. The derivative with respect to x of ry is ry prime plus r prime y. Okay, and we can collapse it in this way so that our equation becomes this. And if we multiply both sides of the equation by dx, then we have d ry q of x r of x dx. And then if we integrate both sides, we get ry is equal to the integral of q of x r of x dx. And then you could say y equals 1 over r of x. This is r of x here. And the integral of q of x r of x dx. Okay, so if we could force, so this would be the solution, if we could force r of x px equals to dr, so we'll say, or we could just say dr dx equals r of x times p of x. Okay, all right, so if we could set this to be true, then going from here to here, okay, if this was true, then the solution is y, as shown right here. Okay, we have to force that to be true. Okay, p of x is known. It's in the equation. It's up here. Okay, but r of x, we need to solve for. We need to figure out what is r of x. What is this thing we're multiplying both sides of the equation? We need it, in the solution here too. So we need to figure out what it is in order to solve for y. Okay, great. Let's go to the next page here. So we need to solve, this is a differential equation. dr dx equals r of x px. Well, we know how to solve this kind of equation. How do we solve this kind of equation? dr dx equals r of x p of x. Well, we know how to do this. We separate the variables and then integrate both sides. Separate and integrate. Okay? So we have the r, okay? So 1 over r, bring it over to the other side, dr. Okay? And I'm going to bring the dx, I'm going to bring it to the right-hand side of the equation. Equals p of x dx. So I've separated them, r, okay? And now I can integrate. Well, what is the integral of 1 over r? Well, that is ln of r, okay, plus some constant, equals the integral of p of x dx. Great. Let me bring this c over to the other side. So this becomes ln of r equals the integral of p of x d of x plus some constant. Well, what's this? What is r? See, ln base e to whatever's on the other side of the equation. So what we have is that r, say r of x, is equal to e to the integral of p of x dx plus some constant, which is e to the integral of p of x d of x plus, actually, times e to the c. We'll call this c naught, just to make life easy. This itself is a constant. Okay? So what we have is we have c e to the integral of p of x dx. Now, the thing is, if you look at r, okay, this is our r of x. It multiplies, okay, it's here, it's on the right-hand side. See, look, we multiply r, r, r. So the constants, we could divide both sides of this equation by that c constant, okay, and the equation would not change. So really, we can basically ignore this constant, okay? So r of x, if chosen to be e to the integral of p of x d of x, if we choose r of x in this way, and we know p of x because p of x is inside of our original problem, it's right here, okay? We can, if we choose r in this way, then the solution is given by this equation right here. So you have equation number 1, and then you have equation number 2. Okay? So really, first you start off, you solve for r in this way, given p of x. You take r and you plug r into equation number 1, and you're done. Okay? Let's see this in action. Okay? Let's do an example of a problem where we can use this to solve it. Okay. Let's go to a simple example. Okay. So, let's say that we're given this problem. dy by dx plus 4 over x y equals 3. Now remember, the form is given up here. dy dx equals p of x times y. Sorry, plus p of x times y equals q of x. Well, what's p of x and what's q of x? Well, in our problem, this guy right here is p of x. This guy right here is q of x. Okay? So our solution is y equals 1 over r q r dx. Now, q and r are functions of x. This is our solution. Okay? But we don't know r, right? So this was equation 1. Equation 2, r, okay, of x is e to the integral of p of x dx. Okay? So once we know r, we can plug it into this equation and we can solve for y. Okay? So these are the two equations. Okay, so let's do that. So r of x equals e to the integral, and what is it? It's 4 over x. So basically I have 4 and I have 1 over x dx. Okay, so what is the integral of 1 over x? Well, e to the 4, this is ln. Now again, I can ignore the plus c from this because r of x is going to multiply both sides of my equation, so I can ignore the plus c. So this is 4 ln of x. Okay, great. Well, a ln of b is equal to ln of b to the a. I need that. So this is the same thing as e to the ln of x to the 4. Okay? All right. Well, this e, this exponent, see this guy right here? E to the box. So this e to this box is x to the 4. This e is to the same box. So this guy right here is just x to the 4. Okay? Now I could have a constant in front if I really want, but again, r of x multiplies both sides, okay, of this equation, okay, and so I can cancel out the constant if I want. I could divide both sides by that. So this is my r of x. So what is y? What is y in this thing? So so that means that y equals 1 over, let me rewrite it just to make it nice and clear. Okay, so I need 1 over x to the 4 integral. Now what was q? Q was just a constant in this problem, right? It was 3. So I can pull, okay, I could just say 3 and then x to the 4 dx. Okay, no problem. So then I can go in, say 1 over x to the 4, or even pull the 3 out. What is the integral of x to the 4 dx? Well, that's just here. Let me just go 3 over x to the 4 is x to the 5 over 5 plus some constant. This matters now. This constant matters because it's being multiplied by 3 over x to the 4. Okay? So make sure that that one is clear. So what do I have here? If I multiply it out, what I have is 3 over 5 x, okay, plus 3c over x to the 4. Well, 3c is just some other constant. I'll just call that c naught, okay? Over x to the 4, okay? So this is the solution. This is the general solution, okay, to the differential equation that I started with up here. Okay, so this is the integrating factor method where we're multiplying by some factor, some function, r of x, both sides of the equation in order, okay, to get the product rule, to convert, okay, to convert our original problem, okay, to convert this original problem into, so we're forcing r of x times p of x to be dr dx, okay, through right here, this guy right here forces it, okay. If we enforce this, then we can make the whole left hand side look like the product rule, which means we can collapse it, okay. If you remember from integrating combinations, this is one thing that we could do. And then we can integrate and really simplify the left-hand side of our equation, okay? And then we're integrating both sides, okay? And we can solve for y very quickly and easily, okay? I hope you enjoyed this video. We'll see you next time in math class.